So these are our trig equations and identities. We are going to talk about reciprocal identities and Pythagorean identities. Simplify with them and then also use them to solve equations. So when we're talking about identities, these are true statements that can be, one thing can be substituted for another. They're equivalent statements. And yeah, so most of the ones we know, we'll do the ones we know first. So these are the reciprocal. Those are the kind that we flip over. So remember when we talked about all of our trig functions had a partner, had a reciprocal partner. We're going to write those down. So sine, remember sine's reciprocal was cosecant. So if you want to go from sine to cosecant, we've got to flip that over, right? Reciprocal is doing 1 over something. So if you see sine and you want to replace it with cosecant, we'll replace it with 1 over cosecant. That is that first identity there. And so in the same way, if you see cosecant, we can replace it with 1 over sine, since those are reciprocals of one another. These are our first two identities. We'll do cosine next. What was the reciprocal of cosine? Do we remember? Y'all can just mouth it. Secant. So 1 over secant. So secant is 1 over cosine. Then the last one is tangent. And tangent is 1 over cotangent, and vice versa. So these are our reciprocal identities. You might say, when we start to simplify, I might say you want to write things in terms of sine and cosine. That means if you have secants, cosecants, or cotangents, you're going to want to switch them to where you're only using sine and cosine. It's going to make things easier for us to cancel out. Okay, so those are our reciprocal identities. We have two that we just call the others. These you might have figured out already, but maybe not. That tangent is the same as sine over cosine. And I'll show you why over to the side. Remember that tangent is opposite over adjacent, right? And that sine is opposite over hypotenuse. So sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Well, if you do opposite over hypotenuse, sine, divided by adjacent over hypotenuse, the h's will cancel out, and you end up with opposite over adjacent, which was tangent. So tangent is just sine over cosine. We can replace any tangent we see with sine over cosine. That might help us to simplify things. Okay? And then if cotangent is the reciprocal, what do you think is going to go on top for cotangent? You can mouth it. The cosine. The cotangent is going to be cosine over sine. All right, let's make sure our phones are put away and that we're paying attention to this. Thank you. The Pythagorean identities come from the unit circle and us looking on our unit circle and thinking that we could draw a right triangle. All right, remember with our unit circle, we could have a right triangle and we would draw it and it would go like this, right? You don't have to draw the circle if you don't want to. And we would have an X and we would have a Y. And then since it was the unit circle, it would be 1. Right? That would be a picture from our unit circle, our X distance, our Y distance, and our 1. Well, if we think about it and think about where this ordered pair would be right there, the X is the sine, the cosine, right? And the Y is the sine. So we could use this and write it using the Pythagorean theorem. X squared plus Y squared is equal to 1, right? x squared plus y squared is equal to 1. Well, x is cosine and y is sine. So cosine squared plus sine squared is going to equal 1, and we're going to use that as our first Pythagorean identity. Sine normally comes first when we write it, just because we think of sine first, but it doesn't matter. It could be cosine squared plus sine squared or sine squared plus cosine squared. But that's our first one. Sine squared x plus cosine squared x is equal to 1. That one shows up on the ACT a bunch. Did I get your scores back yet for the ACT?
Okay, so virtual, I didn't get mine because apparently we were supposed to set up some kind of ACT account, and I didn't get the email about that or whatever, so I couldn't see my
I guess
scores.
they probably sent it to you in an email or something. I don't know. Otherwise, I guess they'll mail it to you. I don't know.
The only thing they did was they made us put our information down
Yeah.
during the ACT. So
Mhm.
whatever email you put down, they sent to you, but that's it. Like, you have to somehow remember your password for like 3 weeks, and then you can get into your account.
Okay.
Yeah, because I took it like outside of school, and like I don't know if it comes to that same email or not. Because I've seen other people get their scores back, but I haven't.
I don't know. I guess you just have to try to go in the ACT.org website and see what you can do there. I'll get them eventually for you guys. It takes about a month for them to upload them into our system where I can see them. But, all right, so yep, that one shows up on the ACT. That is our main Pythagorean identity. Our other ones come from that. But before we write our other two Pythagorean identities, this one can be rearranged to solve for sine or solve for cosine. And that's where we are going to use it a lot today when we're doing our equations. So if I want sine squared by itself, I would just subtract the cosine to the other side. So sometimes I just want to replace sine squared with something. So sine squared is just going to be 1 minus cosine squared x. Does that make sense? If I just subtract the cosine squared, the sine squared will be by itself. So we can rewrite these to make it fit whatever we need. So if you're trying to replace sine squared and change it into cosines, you'll just subtract the cosine over. So you have 1 minus cosine squared. And the same way we can write cosine squared. Cosine squared x is going to be 1 minus sine squared. So that's how we would rewrite the first one. Our second two Pythagorean identities are the last two that we're doing today before we start to do our simplifying. We get by starting with our main one and either dividing by sine or dividing by cosine on those to get our next two. So I'm going to do all the work on the side and then I'll write them underneath. So if I had sine squared plus cosine squared equals 1, that's our normal one. I'm going to put a sine squared underneath every single thing. And since I'm doing it to all of them, it's fine. It's not going to affect the value of it. This is going to transform it into something cool, another identity that we're going to use. So I put sine squared underneath all of them, and we're going to simplify it. And I'm going to write this simplified form here in blue as our second Pythagorean identity. What is sine squared over sine squared? That is 1. Those are the same thing. Okay, 1 plus. What's cosine over sine? Look over here. Do we see cosine over sine somewhere? Cosine over sine is cotangent, right? But since they were squared, we're going to write it as cotangent squared. And then 1 over sine. What is 1 over sine? That is cosecant. So our first Pythagorean identity was the sine squared plus cosine squared. Our second one we got by putting sine squared underneath. That's our second identity that we'll use. Okay. And our third one, what do you think that we're going to put underneath instead of sine squared? Cosine. So I'm going to replace that with cosine squared. Then we're going to simplify that part and see what it looks like.
Okay, so why did you change it?
Because I'm trying to get the third one.
The third what?
The third identity. The third Pythagorean one. There's 3 of them. So our first one we got with our triangle. Our second one we got with just dividing everything by sine squared. And the third one we'll get by dividing everything by cosine squared. You guys don't have to do this process at all on anything. I'm just showing you where they come from instead of me just telling you that 1 plus cotangent is cosecant. Okay, so like where it all comes from. So I put cosine squared underneath instead. Sine over cosine. Do we see sine over cosine somewhere? Yep, and sine over cosine is tangent. I'm going to write tangent squared. Oops, I'm going to do it in blue. Cosine over cosine is what?
1.
1. Okay. And 1 over cosine squared is secant squared. I like to do this because some people get confused, like this is the one with the cotangent, is that with the cosecant, or is it mixed, or what is it? So that's why I always show y'all that if you know the first one, you can get the other 2 just by putting sine squared underneath, simplifying, and then cosine squared if you get stuck and you don't remember which is which. So these 6, 7, 8, 9, 10, 11 identities we're going to use today to simplify expressions and to also solve equations. And the equations we're solving will be we're using the Pythagorean identities. Okay. So simplify means that we are going to take something bigger and make it smaller by replacing what we see with identities that we know. So our tips when we simplify are to write as sine and cosine. That helps a lot in our simplifying. And also our second tip is to try to recognize Pythagorean identities. So look for Pythagorean.
Okay, is it all we gonna write under tips?
Yep.
And that's all we gonna write under simplified expression?
Yep. So now we're going to actually get to work and see how we can take this and change it into something in a more simple form. And again, phone should be put away. This should not be happening. All right, so if I look at problem number 1, cotangent times sine times secant, right? I want to simplify that. Well, what I'm going to do is I'm going to write things in terms of sine and cosine. That's going to help me. In terms of means that I'm going to substitute for one of my identities up here, okay, for my things. So cotangent, there are 2 things that I could choose to pick for cotangent, but if I want everything in sine and cosine, there's one obvious one. So cotangent is 1 over tangent, and cotangent is also cosine over sine. So if I'm trying to write everything in terms of sine and cosine, I'm going to replace cotangent with cosine over sine. So I'm replacing that since those 2 equal each other. Sine is already sine or cosine, so I'm going to leave it. And then secant, what could we write secant as? Look and see what secant equals. 1 over cosine. So where I see secant, I'm going to instead replace it with 1 over cosine. Okay. So now we can multiply across and then we'll cancel. Actually, you could cancel now if you wanted to, if you see something. So I've got cosine x sine x over sine x cosine x. I just go straight across the top, straight across the bottom. I have a cosine on top, right? Can that go away with the one on the bottom? And a sine, and that's going to equal 1. So the same thing on top and bottom, so that just equals 1. So I simplified this expression. My answer was 1. All right, let's try the second one. We have a fraction on this one. So I've got cosine x, right? I'm not going to change that. Divided by, and what is cotangent? There are two things. We could do 1 over tangent, but that's not going to make anything cancel out. I'm going to instead pick cosine over sine. Okay. Now, what do we do if we're dividing by a fraction? What do you do with the fraction on the bottom? You're going to flip it and then multiply. So I flipped this over and I'm going to multiply. What can I put underneath my first cosine so that it's also a fraction? It makes it a little easier to see. Yeah, there we go. Do we see that something might cancel out? Yeah, what's going to cancel out? The cosines will. Cosines are gone. And I have sine over 1, and that is just sine. Y'all kind of see what's going on here? You're looking up there, seeing how you can rewrite it, and then either multiplying if they ask you to multiply. If you're dividing, make sure you're flipping your second one. Okay.
How did you get the 1?
Here, well, this cosine was on the top. I just put a 1 on the bottom, so they were both fractions. Just like if I had a whole number 2, that's the same as 2 over 1. Or do you mean this one in the first problem?
I was talking about the second problem. I get it now.
Got it? Okay, good. All right. So those were ones that were writing it as sine and cosine. Did you notice we didn't have any squares in the problem or anything? Well, if I'm looking at problems like number 3 and number 4, these have.
I have a question. On number 1, why wouldn't it equal 0?
Like if I had 5 over 5, those are the same thing on top and bottom. Okay. 5 over 5 is just 1. Okay. These were the exact same thing. Cosine sine and cosine sine.
Thank you.
Mm-hmm. All right, so if we look at number 3, I notice that I have some squares. I might have to be thinking about Pythagorean, but we have cubes also, so you're going to have to do a little bit of factoring on this just before we get it all into what it needs to be. So if I'm looking at it and I have things that are higher than a second power, there's a chance that I'll have to do some factoring. So if that's the case, look and see if you have anything in common in both terms. Do I see something in common in the sine cubed and the cosine squared sign? There's something that shows up in both of those. Yep, a sine is in both. So I'm going to pull a sine to the front. If I take 1 out of my sine cubed, I'm left with sine to the second power, right? And if I take 1 out of this second term, what's going to be left? The cosine squared, right? Because I took the sine to the front. Everybody okay pulling that sine to the front? That's kind of like y'all did on your last homework. All right. And now
cosine didn't go first.
Huh? On this one? I took this out. I took sine out of both, right? And then I looked at my first term. That was sine cubed. So when I pulled one of them out, I got sine squared there. So this comes from here, and this comes from here.
So it wouldn't be like a +1? Like, cause.
Oh, at the end, there's not a plus sign in between the cosine and the sine. These are multiplied together.
Oh, okay.
It's like if I had x squared y. Like if my problem looked like this, y cubed plus x squared y. There's a y in both. And then I'd have y squared plus x squared left. because that one came out of there. All right, and now, do you guys notice an identity that's sitting there? Sine squared plus cosine squared equals what?
Is the Pythagorean or whatever it is?
Uh-huh. Sine squared plus cosine squared is the same thing as
1.
1. So where you see sine squared plus cosine squared, we're going to replace that with the number 1, because that's what that equals. And sine times 1 is just sine. Okay, one more that we're simplifying. This one looks like it was already factored for us. That was surely nice of them. I have 1 plus cotangent squared. Do you see 1 plus cotangent squared anywhere?
Cosecant to it. Cosecant squared it.
Yep. So that's going to become cosecant squared. So sine squared. I guess these are thetas. That's okay. All right. So now I don't know that that's simplified enough.
Can we just stick with the x's so we don't get confused?
You can write x's on yours. It's the same thing.
Okay.
Yeah. And now I'm going to say, oh, wow, I don't have everything in sine and cosine yet, so I'm going to go ahead and do that. Okay. So cosecant was the same as 1 over sine, right? Cosecant is the same as 1 over sine. When you have the squares, you just put squares with them when you're doing this. So sine squared, 1 over sine squared. Is anything going to cancel?
Sine squared.
The sine squareds will go away. One's on top and one's on bottom, and we're just left with 1. So occasionally you do have a combination where you have to use Pythagorean identities and then also the reciprocal ones. The ones on your homework obviously are multiple choice because you're doing them in CUDA. So if you haven't gotten to one of those answers, no, you have to keep going a little bit further. Questions on the simplifying?
Well, I have a question on number 2.
Uh-huh.
So why did you write it like the answer like that?
Here?
Yeah, like I know it's 1. So
Yeah, the start is 1.
Mhm.
So sine x times 1 is just sine x.
Okay.
I guess I could put it underneath if you want me to. Would that help? I don't know. So I factored it. So that was 1. Anything times 1 is just itself.
Okay.
All right, and the ones that you guys are going to solve, you're going to use the Pythagorean identities. And most of them, I think almost all of them that I gave you, you have to use these 2 that are in the green. You might end up with one that says sine squared plus cosine squared and you just replaced 1. But most of the time, you're just going to change a sine squared into 1 minus cosine squared or a cosine squared into 1 minus sine squared. I think we'll do one of both of those, one of each of them. All right, so if I'm looking at problem number 5, if you're trying to solve this, and if we're thinking about our techniques from the other day, we always try to get the trig function by itself. Well, we have 2 different types So that won't work. And if we factor, it's not going to help us either right now because there's two different types of trig functions. So what we want to do is we want to make a match. Okay, so I have a sine squared and I have a regular cosine. Well, I can't turn a regular cosine into a sine. I can turn it into a secant, but I can't turn it into a sine. But I can turn a sine squared into a cosine so that they'll match. Because I have up here, it tells me that sine squared is 1 minus cosine squared. So I can change it into that. So then all of my trig functions in the problem will match. So I'm trying to figure out what I need to replace so that they're going to be the same, and I'll be able to solve for it. So I saw a sine squared. I'm going to replace it with 1 minus cosine squared. You want me to do x's? I can do x's, that's fine. So where the sine squared was, I just rewrote 1 minus cosine squared. I left that negative out in the front. I'm going to have to distribute it. It needs to go to both of them.
Could you slow down a little bit, please?
I'm going to go faster. Then I'm going to distribute the negative, and then I'm going to, yeah. So this was here, and that became this. Okay, sorry, I had a visitor. All right, so we're good here. We replace the sine squared with the 1 minus cosine squared. Okay. Now we're going to distribute this negative. So I'll have negative 1 minus cosine squared x. No, not minus, plus, sorry. And then minus 2 cosine x plus 2. Is that all right with everybody? Distributing your negative? Thumbs up if we're good? Okay. Now we're going to combine like terms if we have them, and it looks like I have a negative 1 and a plus 2. And we get to practice the problems that we did last time with our factoring. I just wrote the squared term first, then the regular cosine, and then 2 and negative 1 make a positive 1. Now everything is in the same trig function, and we can use our factoring technique from last time. What would multiply to cosine squared? What and what? What do we put in the front? Cosine and cosine. What's going to multiply to 1? 1 and 1. And we want it to add to negative 2, right? So remember, if you like to write out this with x's on the side, that's fine. This is the same as doing like x squared minus 2x plus 1. So do I need plus signs or minus signs in my parentheses? I need minus for both, right? Minus 1 times minus 1 is a plus, and plus a minus is the minus. Now we will set this equal to 0 and solve it. If they were different, we would do both of them, but we only have the one. That's nice. So what are we going to do to get cosine by itself? Add 1 to both sides. So we're looking for when cosine is positive 1. The x value on the unit circle is positive 1. And I think that's at 0 degrees. I'm going to double check though, right? Is that 0 degrees? I think I have a unit circle here from the other day. Maybe. Yeah, cosine is 1 at 0 degrees. Oh, we're in radians, so I guess just put 0 instead of degrees. So the only thing different from the problems that you did before was that you are taking one of these terms, whatever squared it is, and replacing it with a part of your Pythagorean identity. You just have to see which one you need to do. Okay. So y'all ready to try 6? It's our last one for today. So I've got a sine squared in this one, and I have a cosine squared, and I have a regular sine. So which of these identities do you think we're going to replace?
The cosine.
The cosine, right? Because we want everything in terms of sine because we had a regular sine there, and we can't change that into cosine. So I'm going to replace the cosine squared. Cosine squared is the same thing as 1 minus sine squared. So this part is going to become 1 minus sine squared.
Can you scroll back up to where you decided?
Right here.
Okay.
Mm-hmm. Now, is everything in the same trig function? Yep, we're going to move it all to one side and then factor it just like we did below. I'm going to subtract the 1 and add the sine squared. I'm going to put it over here. So that makes how many sine squared thetas on the right-hand side? 2. So 2 sine squared theta.
Why would it be 2 if you just added 1?
We had 1 plus 1. There's like ones in the front. One of them plus another one, and that makes 2 of them.
Okay.
Mm-hmm. All right, and then it doesn't look like we can pull something out of everything, so we're going to have to try to factor again. We're trying to make 2 sine squared theta. So I know I need a sine and a sine, but one of them needs a 2 in the front. So 2 sine theta and sine theta. And how can we get 1? What multiplies to 1? 1 and 1. Okay. And then I want it to be a positive sign in the middle. So let's see what we need to do with our plus and minus. That's going to be 2 sine theta. And that's 1 sine theta. And I need a positive 1. So which one of these needs to be the negative? Which one do we need to subtract? Do we need to subtract the 2 or the 1? Make a positive 1. And you subtract the 1, right? So that needs to be our minus. That needs to be our plus. So our plus goes here. Our minus would need to be here. So that would give me the negative sign that I want and the positive 2 sign to get a positive in the middle. If it was a negative in the middle, we would swap those. Now we'll set both of those equal to 0 and solve them. Bet y'all can do this part. This isn't the, that's like the first lesson we did. You're good at those. From the first equation, we're looking for when sine is equal to what? When you solve it, sine is going to equal 1/2, right? We add the 1, divide 2, so sine, we're looking for when that's a half, and then on the other side, we're looking for when it is -1. We write down all the times that sine is a half and when it is -1. So let's see. Go back to my unit circle. Sine is a half at pi over 6 and 5 pi over 6. And it is -1 at 3 pi over 2, if you're using your unit circle. Remember, sine is the y value. Any questions on that last one?
The where you